Hey guys, welcome to Unit 8, Lesson 1. Our topic today is implicit differentiation. So what is implicit differentiation, right? Some equations, like in the past when we did our power, product, quotient, or chain rule, any of those rules we used, what were we doing? They were all solved for y, and we were just differentiating with respect to x. But now when some functions, it's hard to solve for a single variable. So that's when implicit differentiation comes into place, okay? So let's try the warm up. Pause the video and see if you can solve for y and do it. So the first thing we're going to do is solve for y. So what do? I can factor out the y here, and what am I left with? X plus 1, and I'm going to move the y 1 over. So it's equal to x minus 1, right? Solve for y equals x minus 1 over x plus 1. So I'm going to take the derivative. I'm going to use the quotient rule, which is what? A prime b minus ab prime over b squared, where a is your numerator and b is your denominator. So this is your a, this is your b. I think we're all pretty good with it. So it's going to be x plus 1 square. And now what is my numerator? Derivative, it is just 1 times x plus 1 minus, it's minus, guys, please be very careful. I've seen some students putting plus there. Please be very mindful of that. And it's always the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So be very careful of it. If I simplify, I get what my x's actually will cancel out, right? So I'm left with x plus 1 minus x plus 1 over x plus 1 square. The x's cancel out, so my derivative is 2 over x plus 1 square. So it was pretty simple to solve for y here, and then we just took the derivative using the quotient rule. How would you find the derivative in the equation x squared minus 2y cubed plus 4y equals 2, where it is very difficult to express y as a function of x? To do this, we use a procedure called implicit differentiation. That's what I was talking about. Implicit, oh, I spelled it wrong. Implicit differentiation. The differentiation that we've been doing in the past is called explicit, and this is implicit. This means that when we differentiate terms involving x alone, we can differentiate as usual. But when we differentiate terms involving y, we must apply the chain rule. So that's what you're going to be doing, and you'll see it when we do a question. Most of the time, we use implicit differentiation when we're dealing with curves that are not functions, with powers of y that greater than 1, which cannot be solved explicitly for y. Note, when we differentiate implicitly, we must show that we are taking the derivative of both sides. Please make sure with respect to x. What does that mean? Let's do a question. I want you to, again, just watch the first question and then copy the notes, because when you're copying the notes and watching, sometimes it can be confusing, especially as these are more challenging topics we're getting into. So we all know that this is another form of writing the derivative, right? So we are going to, example 1 says find the derivative for the equation, and this is an equation of a curve. So what are we going to do? We're going to take the derivative. The first thing to do is take derivative. I'm going to write down the steps also so that we understand it. Derivative with respect to x. That's what we're going to do. That's the first thing we're going to do. The second thing we're going to do is, let's first do that, and then I'm going to do the steps each time. So it would be what? 2x minus, when you have a y term, we'll do the chain rule, and it'll be what? 6y squared times, either you can choose to write dy over dx, or you can just write y prime, plus, because it is with respect to x, not respect to y, so 4 dy over dx or y prime equals, a derivative of a constant is 0. So that's what I meant by taking the derivative on both sides. So here, what do we do then? Now you want to solve for dy over dx, or you can just call y prime, any of these things, whatever you used, it's fine. So I am going to move the 2x, subtract 2x onto both sides, and I'm going to factor out dy over dx here. So if I factor out dy over dx, I'm left with negative 6 y squared plus 4, because we want to find dy over dx, right? Equals negative 2x. Do we all agree? Now, what do? I want just this by itself, so I'm going to divide. So dy over dx equals negative 2x over negative 6y squared plus 4. And that's basically it. So now step number 3 is solve and simplify if possible. So dy over dx, the 2 goes into all of them, so I can factor out the 2. It will be negative x over negative 3y squared plus 2. So that is your answer. We good? Okay, so this is how we do implicit differentiation. You are taking the derivative on both sides. So here, I already see I'm going to be using the product rule. So I'm going to not use dy over dx, instead I'll use y prime. So it doesn't matter. You can use either dy over dx or y prime. I don't have a preference over it, but be very careful when you're writing y prime. The prime should be easily accessible. If you don't see it, if you know you're going to get confused with between y and y prime, you want to stick to dy over dx. So it's totally a matter of choice. So anyways, so we're going to use the chain rule, not the chain rule, sorry, product rule. So it'll be what? 2xy plus x squared, derivative of y is 1, so it'll be what? I said I'll use y prime. X squared y prime, right? Plus, again, here also we're going to use the product rule. I'll just write down the product rule if a prime b plus ab prime. So it's going to be 1y squared plus x times 2y y prime, right? Times, it's all times, equals derivative of a constant is just 0. So that's your implicit differentiation. That's what you took the derivative part. Now it is just simplifying or solving for y prime. I'm going to put the y prime terms together and factor out y prime. So what am I left with? X squared plus 2xy. And I'm going to move these terms onto the other side. So I have negative 2xy minus y squared. Right? Do we all agree? Now I want y prime by itself, so I'm going to divide by x squared plus 2y. So I have negative 2xy minus y squared over x squared plus 2xy. And that's it. Not too crazy, but you have to remember what you're doing, know how to write it. So I want you to finish the remaining of the problem set. Good luck, guys.